Okay, now we're getting to the fun part of the lecture. I want to ask you a question. Let's just for a moment think that we had a trigram language model. Let's just pretend for a second. And this trigram language model assigned the probability of 0 to the words commend, given that the previous words were like to. Okay? So let's just for a moment pretend that in the training set for this specific case, the words like to commend never occurred. Okay? Like to commend never occurred, which means this language model assigns a probability of 0 to that specific sequence of words. Okay? If this happened, what would be the perplexity here at the bottom of this sentence? So I would like to commend the rapporteur on his work, okay? And everything else stays the same except for commend, given like to as the preceding words, has a 0 probability. What would happen to the overall perplexity of this trigram model? Okay, I can write out just the definition of perplexity again. So perplexity is basically the probability of seeing this sequence of words and then normalized by 1 over the number of words, negative that. Okay? So if this happens, what is the probability of this sequence according to my trigram language model? Okay, the probability would be 0 and the perplexity would be, so you're dividing by 0 and the perplexity would be infinite. Okay? Do you think that's reasonable? You think this is a good thing? Like, it's a little bit crazy. Like, let's say this specific language model actually had very, very, very good probabilities for all the other words, but except for these 3, it messed up and it just had a probability of 0, just for these 3. But the rest of the words are excellent, like really, really good probabilities, high probabilities for the rest of the words. But just for these, like to commend, you have low probability. Okay? And just because it never saw these 3, now it gets a perplexity of infinite. Okay. Or to put this another way, just because I've never seen these 3 words occurring together, I've assigned a 0 probability to any sentence that contains these 3 things in sequence. So this is the problem with unseen n-grams. When you have an unseen n-gram anywhere in your corpus, then you would just get an infinite perplexity, or you would assign a 0 probability to any sentence containing these 3 things. Okay? When that happens, right, when you're assigning a probability of 0 to something that is never seen before during training, the model is really, what's happening is it's overfitting to the training data, because it's saying, because I never saw this during training, I'm going to assign it a 0 probability at test time, at inference time. And how do you combat overfitting in machine learning land? We regularize, okay? And in n-gram language models, the way that you're going to regularize is often it's called smoothing or discounting, okay? And it's ways to basically combat this problem of dealing with unseen events. We've got the running example where we maybe have a corpus with denied the allegations 5 times, denied the speculation 2 times, denied the rumors once, denied the reports once, but denied the offer has never been seen and denied the loan has never been seen. So any sentence containing denied the offer anywhere would cause your model to basically say this whole thing has a 0 probability. Okay? So if you have he denied the offer to go to the Supreme Chancellor, this silly example from Star Wars, then that would get a 0 probability immediately. So the idea behind additive smoothing is, let's say we're looking at this problem where we've got trying to get the probability of a word given that the preceding 2 words were denied and the. Okay? And let's say there's some probability on denied the allegations, denied the speculation, denied the rumors, denied the report. But there's no probability on denied the offer, denied the loan, denied the dog. That doesn't make sense, okay? But there's 0 probability on that. The idea behind additive smoothing techniques is that what we're going to do is we're going to take some of the probability mass that were assigned to allegations. We're going to remove it. going to steal it. Okay? Take some, just a little bit, not everything, just a wee bit. Take some of the mass from rumors, some of the mass from report. And then what we're going to do is we're going to take the mass that we stole and we're going to redistribute it to things that we've never seen. So we're going to put just a little bit of mass here, and a little bit of mass here, and a little bit of mass here. And this will solve our problem, because now when it says denied the offer, where before it assigned absolute 0 to that, at least now we're giving it a little bit of a weight. So it doesn't immediately drop the ball and say that probability for this whole thing is just 0. Okay, is everyone with me with the intuition of additive smoothing? And there's several different approaches that we can use for smoothing, and we're going to look at 3 or 4 or a few. Okay, we're going to look at a few of them. Okay.